In example 1, we're given a Boeing 747 starts out on an average cross-country flight with about 57,260 gallons. I'm just going to box that in. That's probably going to be important later. Depending on the weight the airplane is carrying, it will use an average of 4 to 7 gallons of fuel per mile. If it's lighter, it's going to use probably closer to 4, and if it's really heavy, it'll probably use 7. So these numbers are going to be important here, 4 to 7, so we've got a range of values. We want to write a rule to show the 747 uses exactly 5 gallons of gas during the flight. Is this an equation or an inequality? I'm going to underline here an equation and cross out inequality. We see the word exactly. The rate is 5 gallons, so those are some words that clue us in that this is going to be an equation. So we're going to let maybe F equal the amount of fuel left, and we're going to let's see, gallons per mile, so we're going to let M equal the number of miles. So if we write F, we know that our rate is going to be 5 gallons, and we're using that up. So that's going to be negative 5m, and then we can do plus 57,260. So it's a little bit ambiguous to write what rule should we exactly show, but this is a good one. You wouldn't be wrong if you said, well, I'll write a rule to show the 747 uses exactly 5 gallons of gas per mile. Should be per mile during flight. Forgot about that. You could write the fuel used, so you could say let F equal the fuel that's used, and just set that equal to 5m. That'd be fine. But this is a nice equation right here. Oftentimes you want to know how much fuel you have left if you're flying around. We're going to write a rule to show the 747 uses at least 4 gallons during the flight. Is this an equation or an inequality? This time I'm going to cross out the equation, and I'm going to underline the inequality. At least, or at most, those kind of words indicate that we're going to use at least this amount. I'm going to leave this area blank here. We're going to decide on the symbol just a little bit. At least, though, that means it could be exactly 4. So I'll leave this equal to sign underneath. And we know our rate is going to be negative 4 gallons of gas. Again, this is per mile. During the flight. So let's see here. Okay, and we got plus 5,000 or 57,260. So when I'm trying to figure out the fuel used and figure out which inequality symbol this is going to be, we know that the fuel for this airplane is at 57,260 to begin with. We know that as we go, let's say this is 1 mile, then the fuel used will be a little bit lower. But we want to know, this says write a rule to show the 747 uses at least 4 gallons of gas. So in this case right here, if we had negative 5m or more, that would be fine as well. So this number would be a little bit lower. I'm going to write this less than or equal to right here. So this rate could be a little bit higher, and we know that the fuel left could be lower than this entire possibility right here. This is the least amount of gas that you would use, but if you use more, then you'll have less total fuel. So the fuel could be lower than or equal to that equation or that expression here on the right. We've got another part of this. So we're going to write a rule here to show that the 747 uses at most 7 gallons during the flight. Is this an equation? No, the words at most to me, the Y part is at most here, tell me you could use at most 7 gallons of gas, and it's definitely an inequality. So we'll do F. We know it could be equal to, and we've got negative 7m plus 57,260. This case, because we're lowering the amount on the right hand side. The gas actually could be, if we use a little less per mile, and again this is going to be per mile. If we use a little bit less gas per mile, there's going to be more left over. So this piece right here will be the lowest that you could, or the lowest amount of fuel that you could have, and you could always have greater than this amount here. So this is the rule that I'm going to use in this case. Of course, it wouldn't make sense if F was bigger than 57,260. When the plane lands, it has about 2,300 gallons left. How far did the plane go? Is there one solution or more than one solution? In this case, there could be a few different solutions. So let's go with high gas usage here. So that's going to be 7 gallons per minute. And then let's go with low gas usage here. And that's going to be that 4 gallons per minute. Let's see if we can figure this out. So what we'll need to do is we'll need to take 2,300, oops, let's do 57,260. We're going to subtract 2,300. So the airplane used 54,960 in flight. And then we'll just divide that by 7 to figure out how many miles. So it's about, we'll round to the nearest mile here, 7,851 miles. And then we can do the same thing here. 57,260 minus 2,300, that's our 54,960. This time we're going to divide that by 4. So the airplane could be 13,740 miles down the road, depending on how heavy it is. The heavier it is, the more gas it uses, can't go as far. And here, the lower gas usage, it's real light, so it's going to go a little bit further. We're going to write an inequality for this, though, because the answer could be really anywhere in between here. So we're going to start with our lower number here, 7,851. And it could be less than or equal to, and the variable we used before is m, so we'll stick with that. We've already defined it. And then we could be less than or equal to 13,740. So anywhere in the middle here, we're good to go if the plane had a different usage rate between 4 and 7.